the total conduit diagram. Okay. The total switchboard connection diagram. So this is the conduit layout. And first we will consider only one unit. So as you can see, in one unit we have bedroom 1, toilet 1, kitchen, dining room, toilet 2, bedroom 2, and drawing room. Right. Now, if we go to bedroom 1, we can see there is switchboard 1, SB1. And SB1 is connected to F2 through this blue wire, and then TB1, and it is also connected to SB2, and it is also connected to LB2. Right? We can also see that SB1 is connected to SB2. This is the SB2 and this is the SB3. So actually we can write something here like, so basically SB1, you can see SB1 is connected to 4 things. What are the things? First, it is connected to SS1. This is SS1, right? So this is SS1, and it is then connected to, it is also connected to F2. So this fan is F2, and it is connected to TB1, and it is connected to LB2. Okay. Did you understand this diagram? Then we can see that SB1 is connected to SB2. So this is the SB2. So we can say that it is connected to SB2. And SB2 is connected to LB10. This is LB10. So we will give another switch and we will write LB10. So there is no space writing here to write here, but we can see that SB1 is also connected to SB3. So we can take it, let's say this is SB3, and then SB3 is connected to LB3 and SS5. Okay. So this is the connection of the blue lines in bedroom 1. So if we draw these diagrams in a nice fashion, you will see something like this. Let's say this is SB1. Then SB1 is also connected to switchboard 2. We have seen it, right? And switchboard is connected to only light bulb 10. And switchboard 1 is also connected to switchboard 3. and switchboard 3 is connected to SS5 and LB3. Okay. Now, if we go back to the PDF, and we go to bedroom 2. So you can see this is the bedroom 2, right? This is the bedroom 2. So here we can see the switchboard is SB4 and it is connected to LB6, F3, TB2, and SS2, right? So we can write switchboard 4 is connected to SS2, F3, TB2, LB6. LB6, okay? And then let's go to drawing room. So this is the drawing room, right? So in drawing room, you can see SS3, sorry, SB5. SB5 is connected to SS3, F5, LB7. That's it. So SB5 is connected to SS3, F5, LB7. LB7. Okay. Then to dining room. So where is the dining room? This is the dining room, right? In dining room, you can see the switchboard is SB6. So SB6 is connected to SS4, F7, then LB8. So this is the LB8, right? SS4, F7, LB8. SB6. SS4, F7, LB8. No, yes, LB8. Then kitchen, right? So this is the kitchen. So in kitchen, we can see connection is coming from SB7. So SB7 is connected to LB11 and EX1, exhaust gas, sorry, EX1, right? Exhaust fan. SB7, EX1, and LB11. Then the last thing left in the unit is the corridor. So here you can see we have a corridor between the two units, right? So you can see that ceiling light, there are two ceiling lights, LC1 and LC2, which are connected to switchboard 8. So as we are considering the unit at the right side, we will write LC2 connected to switchboard 8. So SB8, LC2. Okay. So let's say This is circuit 1. This is circuit 2. This is circuit 3. Circuit 4. Circuit 5. Just to let you know, switchboard 8 actually gets connection from switchboard 7. So if you can see it, switchboard 8 actually gets connection from switchboard 7. So okay. So there are a total 5 circuits, CKT 1 to CKT 5. Now, if we want to calculate the ratings, the current, how many current it will be needed? We can calculate it, right? So let's calculate it. Let's first calculate the CKT 1 rating. So before calculation, we will assume tube light is 20 watt, ceiling fan is 100 watt, switchboard socket SS is 100 watt, ceiling light LC is 20 watt, and energy saving bulb, that is LB, is 20 watt. Okay. Now, CKT1 rating, we know that I P equals to VI cos theta, right? So I equals to P by V into cos theta, or you can say power factor. So what will be the P? In circuit 1, you can see in circuit 1 we have one SS1, right? So for this SS1 we will write 100 plus, for F2 we will write 100 plus, for TB1 we will write 20. For LB we will write 20. So these four are the loads in switchboard 1, connected to switchboard 1. And then light bulb 10. For light bulb 10 we will write 20, and for SS5 we will write 100, and for LB3 we will write 20. Okay, then divide it by 220 into 0.7. Now some of you tell me what will be the current value. Quickly do the calculation. Fast, 1 minute.
Ma'am, 2.47.
2.47 ampere. Okay, good. So 2.47 ampere. So this is less than 5 ampere, right? So if we now go to the table, this is the table. So we can see that this is the ampere rating. So we can use 1.5 RM cable, right? So we can write it here. We need 1.5 RM BYM cable plus 1.5 BYM ECC. Okay, so this is CK21 rating. So now someone tell me the CKT2 rating, the current value, CKT3 rating and CKT4 rating. Who told me the previous value? Hello?
Yes, ma'am.
You calculate the current of CKT2, current rating of CKT2.
Okay, ma'am.
ID 103 calculate the current rating of CKT3, 111, CKT4, and one 121 CKT5. Quickly, if you cannot tell me the current value, I will give absent. 2 minutes. Two minutes time. I have given SS is 100 watt, F is 100 watt, TV is 20 watt, LV is 20 watt. Quick.
Ma'am, TB and LB কি 20 watt হবে? 20 watt করে হবে?
TV tube light, LV light bulb, দুইটাই 20 watt.
Ma'am, could you please repeat the question?
You need to calculate the current rating of CKT2, CKT3, CKT4, CKT5. 2 minutes time.
CKT.
Like I have done for CKT1 rating, right? Just tell me the current value. After 2 minutes, I will ask. I will call random IDs and will not be able to tell me. I will give absent. We do not have a lot of time.
Ma'am, circuit 2 এর জন্য আসে 1.56.
Okay. Circuit to 1.56 ampere. Then
Ma'am, exhaust fan এর rating টা কি?
exhaust fan দেখিনি এখানে। আচ্ছা, wait. Exhaust fan, right? Exhaust fan is switchboard 7, that is circuit 5. 60. Exhaust fan is 60 watt. What is the current in circuit 3?
Ma'am, 1.43.
1.43. Yes, good. Circuit 4.
Ma'am, 1.43. এটাও 1.4,
and circuit 5
0.65.
0.65 ampere. So as you can see, all the amperes are below 5 ampere. So for all this, we can use the same cable, that is 1.5 Rm BYM plus 1.5 BYA ECC. So we need to show this in the switchboard connection. We will show this like this. Okay. So this is the, sorry, I forgot to wrote 2 into 1.5 Rm BYM. And what will be these two conduits? SB2, these two will also be same. Okay. Then this one. So we have written down what conduits we will use for these connections. Okay. So our switchboard connection diagram is done. In your project, you need to draw it in AutoCAD. Draw the whole switchboard connection diagram in AutoCAD. Okay. Now we will move to emergency switchboard connection diagram. So again, if you go to bedroom 1, you can see there is ESB1. I have told in the previous class that for both SB and ESB, you will use the same switchboard. That is, I'm showing it again here. Let's say this is the switchboard diagram. Okay. And you will write SB1 here, ESB1 here, which is practical, because when there is load shedding, you do not need separate switches to keep your light on, right? So let's say so if there is overlaps, you know, we use a S sign and blue color for normal connections. Did you understand what I said? You will not use separate switchboards for emergency, separate emergency switchboards. You will not use that. You will use the same switchboard, but inside this switchboard there will be connections coming from both the generators and the main grid. Okay. Now, so in bedroom 1, you can see we have the ESB1 here, and ESB1 is connected to F1, LB1, right? Only two, yes. F1, SB1, and this thing, ESS1. So let's write it down. ESS1, emergency switchboard socket 1, then fan 1, then light bulb 1. Okay, let's tell it circuit 1 prime. Then ESB2. Now, this is ESB2, right? So ESB2 is connected to LB9, then LB4, then there is no other connection. So LB9, LB4. Let's tell it circuit 2 prime. Then ESB3. We have seen that ESB1 and ESB2 goes directly to the ESDB. Now we will find out ESB3. So can you see ESB3? This is ESB3, right? So ESB3 is connected to F4, LB5, then it is connected to ESB4, then it goes to ESDB. So LB5, F4, and ESS2, ESB3. ESS2, LB5, F4. Okay. One thing I forgot to tell you that you also need to show what type of conduit you use here from switchboard to the appliances. So we also need to show that. We know that all the appliances here, they do not draw more than 5 amperes. So we can use 1.5 RM BYM cable. And there is no SSC required for these connections, like for the conduits which are connected to switchboard, connected from switchboard to the appliances. Okay. Then let's call ESB3 PKT 3 prime. Wait. We have seen that ESB3 is not directly connected to ESDB, right? So let's first draw the ESB4 diagram. ESB4, ESB4. Sorry. This is ESB4 and ESB4 there is ESS4, TB3, F6, these three. Okay. Okay. And now we know that ESB3 and ESB4 are connected. And we know that ESB4 is connected to ESDB, so we can call it circuit 3 prime. Then the conduit is actually circuit 3 prime. All these wires go to actually ESDB. So you can also write here ESDB, ESDB, ESDB. But I'm not showing here because you need to use a circuit breaker here, which I will add sometimes later. Okay. Then ESB5. Where is ESB5? Can anyone see ESB5? This is the ESB5. So ESS3, F8, ESS3, F8, and this connection, TB4. ESB5. So there are total 5 emergency switch ports. So let's name it CKT4 prime. So it also goes to ESDB. And all these circuits, this goes to SDB. Okay, SDB, SDB, SDB. Now we will calculate the current rating. Now someone tell me the currents in CKT 1 prime, 2 prime, 3 prime, and 4 prime. Quickly. Fan is 100 watt, light is 20 watt, switchboard socket is 100 watt.
1.43 ampere, circuit 1 prime.
1.43 ampere. Good. Circuit 1 prime, 1.43 ampere. 2 prime. Circuit 2 prime. What will be in the numerator? 20 plus 20. And in the denominator, there will be 220 into 0.7. What is the value?
Ma'am, 0.26.
0.26 ampere. Okay. And for circuit 3 prime, in the denominator we have 100 plus 20 plus 100 plus 100 plus 100 plus 20. Hmm. Could you do it? Circuit 3 prime. I don't have calculator. I didn't bring calculator today. I do 125.
It's going to be 1.428.
1.428. Circuit 3 prime
Yes, ma'am.
or circuit 4 prime. Which one did you calculate? This one.
Yes, ma'am. Circuit 3 prime.
1.248. Calculate again because there are more loads here. You can say there are less loads, but we have got 1.43. So there are more loads here, so the current should be more than 1.43, right?
মিস লাইটের জন্য রেটিং কি 20 ছিল না LV5?
Mm-hmm.
Miss, I am getting 2.86 ampere.
Okay,
I also got 2.86.
good. And circuit 4 prime,
1.43 ampere.
okay, 1.43 ampere. So this will be same as the circuit 1 prime because the loads are same, right? So as we can see, all are less than 5 ampere. So again, we can use 2 by 1.5 Rm BYM cable plus 1.5 Rm, sorry, 1.5 BYACC. So we need to show it to the circuit diagram. And this cable will also be the same. And these cables into 1.5 Rm UIM, but no ACC. Okay, so our emergency switchboard connection diagram is complete. Now we will move to the sub-distribution board or SDB diagram. So let's say this is the SDB. And SDB will get connected to MDB via a circuit breaker. Now we already know that total 5 circuits are coming to the SDB, circuit 1 to circuit 5. CKT1, CKT2, 3, 4, and 5, right? Now we have not yet considered the 3-pin sockets. So if we go back here, let's go with massive. So again, we need to find out how many 3-pin sockets are connected to the blue lines. So you can see Q3, right? So I'm writing here Q3. Q3 is connected to blue lines. P3 is connected to blue lines. Then Q2 is connected to blue lines. Then P2 is connected to blue lines. Then Q7. Q7 is connected to blue lines. Q4 is connected to blue lines. Q1 red. Q1 red lines. P1 red lines. P1, Q1. Q6 red. Q5 red. And P4 red. Right? So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. We have also got 11. So P2, P3 and Q2, Q3, Q4, Q7. So we can write that P2 and P3 are connected to SDB via circuit breakers, and Q2 so this lab will take a lot of time because I'm going to calculate the whole, I'm going to do the calculation of the whole project, Q2, Q3, Q4, and Q7. Okay. So now we need to calculate what type of circuit breakers we will use. So we have told you that, let's say for P2, we use, let's say this P2 can support 3000 watts and Q can support, let's say 4000 watts. Give me 1 minute. Three thousand. let's say we use, let's say P2 and P3 can draw, can support up to 15 ampere. Okay, so we can use 15 ampere single pole molded circuit breaker. And let's say the Q port support this port support, let's say 20 ampere. So we can use 20 ampere single pole molded circuit breakers. Now we need to calculate the rating of this circuit breaker. But we already know that circuit 1, circuit 2, circuit 3, circuit 4, and circuit 5. All these lines draw less than 5 ampere. So we can use here 5 ampere single pole molded circuit breaker. Okay. And we already know that all these conduits are 2 into 1.5 Rm BYM plus 1.5 BYA SSA. Okay. Now to support 15 ampere, these two, we need to go to the table. So here you can see for 15 ampere, we use 4 Rm cable, right? So we can write 2 into 4 Rm BYM plus 4 Rm BYA SSA. And for 20 ampere, you can see we use 6 Rm for 20 ampere. Can you see my cursor?
Yes, ma'am.
For 20 ampere, we can use 6 Rm. So two into 6 Rm BYM plus 6 Rm BYA SSA. Now we need to calculate what type of circuit breakers we will use here and what type of conduit we will use from SDB to MDB. Before that, we need to calculate the total load of SDB, right? Okay. Now we will calculate the SDB rating. SDB load is total load into 0.7. 0.7 is the load factor. Remember, I told you in lecture 1 that not all the appliances are kept on all the time, right? So we have assumed that the total loads can be on up to 70% of total time. Total P socket load. And let's assume this 0.2 and total Q socket load And let's assume this, we only use this load only 20% of the time, 0.2. So 0.7, 0.2, 0.2, these are load factors. Like activity factor. Okay, so we need to calculate the total load. And now total load is basically circuit 1 load, circuit 2 load, plus circuit 3 load, circuit 4 load, circuit 5 load. Now we need to go back here. Yeah, right? So can you tell me what is the total load? Quickly, take a calculator. SS is 100, F is 100, 100 plus 100 plus 20 plus 20 plus 20 plus 100 plus 20 plus, does you calculate the total load? Calculate the total load. 131. Can you do it? Did anyone understand my question? Hundred plus. Am I audible?
Yes, ma'am.
20 plus 20 plus 20 plus 100 plus 20 plus 100 plus 100 plus 20 plus 20 plus 100 plus 100 plus 20 plus 100 plus 100 plus 20 plus 60 plus 20 plus 20. What is the total value?
Yes, 1160, 1160.
Good. 1160. What? Total load. Okay. So, total load is our calculated total load 1160 watts. So 1160 into 0.7. Now total P socket load. So how many P sockets were in the connection diagram? 2 P sockets, right? And we have assumed that the P socket load is 3000 watt. And we have also assumed the load factor is 0.2. In total Q sockets were 4 Q sockets, right? And we have assumed 4000 watt, 0.2. Remember, you can assume different wattage, like if you connect your AC to P socket and geyser to Q socket, you can assume different wattage values, spectacle values. I don't know, but it should be more than 2000 watts. Okay, 2000, 4000. So can you calculate this and tell me the total value, total watt?
5,212.
Hmm?
5,212.
Okay. So this is the total SDB load. And if we want to calculate the SDB current is 5212 divided by 220 into 0.7. What is the value?
33.84.
33.84 ampere. Now we will go to the table and find out what type of conduit we can use. 33. So you can see there is no 35. After 30, we jump to 40, right? So we need to use 16 RM cable, right? 16 RM cable and 40 ampere single pole MCCB. So circuit breaker will be 40 ampere circuit breaker. Okay. and the conduit will be 16 RM cable, 16 RM wire. So we need to write it to the connection diagram. So now we will go to the connection diagram. Where is the connection diagram? Here. So here we will write 40 ampere single pole MCCB and 2 by 16 RM BYM plus 16 RM BYA ACC. So now our sub-distribution board diagram or SDB diagram is complete. Okay. Now we will go to the emergency sub-distribution board diagram. Emergency sub-distribution board diagram. So there will be EMDB through circuit breaker. We will give connection to the emergency sub-distribution board. So we already know that 4 circuits are coming to the ESDB. Circuit 1 prime, 2 prime, 3 prime, 4 prime. Right? We have already done those calculations. So we already know that all these connection diagrams, all these cables do not draw more than 5 ampere. So we will use 5 ampere single pole circuit breaker, and all these cables we have already calculated. These are 1.5 RM BYM plus 1.5 RM BYA ACC. Okay. Now we have seen that how many P loads and Q loads? 2 P loads, P1 and P4, and 3 Q loads, Q1, Q5, Q6 are connected to the red wires. So we will write P1, P4. And again, we will use here 15 ampere SP MCB and 3 Q1, Q5, and Q6, right? Q1, Q5, Q6, right? So this will be 20 ampere MCB. Now we have seen that for 15 ampere we use 4 RM cable from the table, right? And for 20 ampere we use 6 RM cable. Okay. Now we need to calculate this thing and the current rating of this wire cable that connects EMDB to ESDB. But there is another connection which is connected to there is another ESDB in the ground floor. Okay, so that is called ESDB ground. So the project I am showing you in this lecture. So there are total 6 floors. 6 floors, first floor, second floor, third floor, fourth floor, fifth floor, and sixth floor, and ground floor. Okay, so total 6 floor and ground floor. So here you can see that this is ESB 9. ESB 9. So if there are total 6 floors, so there will be total 6 ESB 9s, right? So all these emergency switchboards goes to the emergency subdistribution board, which is situated in the ground floor. So we can write these are the lights used in the stairs, right? So you already know staircases we use lights. ESB 9. Let's say this is the first floor. This is for second floor. And this is the switchboard for third floor. Fourth floor. Fifth floor. And sixth floor. And we use just a 20 ampere light here, so we can safely say these lights will not draw more than 5 amperes, so we can use 5 ampere as PMCV here, and we can safely use 1.5 RM cable here. Because all these are just 20-watt light bulbs used in the staircase room. 1.5 RM BYA. Now this emergency SDB is also connected to the EMDB, right? So we also need to do calculation to find out what type of circuit breaker and what type of cable we are going to use. Okay. Now we will start calculating. Wait 1 minute. So calculations for ESDB. ESDB load equals to again total load into 0.7 plus total p-socket load into 0.2 plus total q-socket load into 0.2. Now total load is the total load of circuit 1 prime, 2 prime, 3 prime and 4 prime. Okay, and let's say assume P load is again 3000 watt and Q load is 4000 watt. Now let's go to the ESDB connection diagram and calculate the total load. Now again, can you tell me what is the total load here?
1160.
1160, 100, 120, right? 20, 20, 100, 20, 100, 100, 120, 100, 120. 200, 300, 400, 500, 600, 700, 800. 900. Am I missing something? Wait. 900, 1000, 15, 4, 5, 6, 7, 8, 900.
হ্যালো দিদি ব্যায়াম করে কথা বলছি
Please wait 1 second. All right, can anyone else calculate? I am not getting the same value.
ম্যাম 920 আসে কি?
আমার তো 920 আসে।
ম্যাম যা লিখছেন ওই অনুযায়ী 920 আসে।
120, 100, 120, 120, 100, 120, 100, 440.
I'm 920
একটা, দুইটা, তিনটা, চারটা, পাঁচটা, 6, 7, 8, 9, 10, 11, 12, 13, 14. আহ 440 দিয়ে গুণা কত হয়? 880, 880 আর 40 কত হয়? 920, রাইট? 920।
ইয়েস ম্যাম।
তাহলে হচ্ছে 920 into 0.7 plus total P socket. Total P sockets are 2 P sockets right there, and 3000 into 0.2, and we have seen there are 3 Q sockets connected to the red lines. So 3 into 4000 into 0.2. What is the total value?
4244.
4244. What? Can you tell me the current value?
27.56.
27.56 ampere. Now let's go to the table. From the table, we can see that no 20. So we need to use 30 ampere circuit breaker and 10 RM cable, right? 10 RM cable and 30 ampere. So we will write here that 30 ampere single for MCCB is needed from ESDB to MDB. Another calculation is left, that is the ESDB ground calculation. Okay. Our ESDB ground calculation is ESDB load, ESDB ground load equals to how many bulbs we have used? 6 bulbs in 6 floors, right? So 20 into 6, and let's say load factor is 0.7. What is the value?
84.
84. Okay. And now 84 watt. Now we will find out ESDB ground current, which will be 84 by 220 into 0.7. What is the current?
0.54.
0.54 ampere. So we can say, so you can see basically from the table that the lowest is 1.5 RM, right? Lowest is 1.5 RM, table 5 ampere rating. So we can say we will use 5 ampere SP MCCB as circuit breaker and 1.5 RM cable. Okay. Now we need to include these things to the connection diagram. Now let's get back to the connection diagram. EMDB. So here we got 30 ampere SP MCCB, and as it was for ESDB ground, the current value was really less, so we told you that we will use 5 ampere SP MCCB. And for this 30 ampere, we have seen that we need to use 10 RM cable. 2 into 10 RM BYM plus 10 RM BYA ECC. And for 5 ampere, we usually use 1.5 RM cable, right? 2 into 1.5 RM BYM plus 1.5 RM BYA ECC. So now our emergency subdistribution board diagram, ESDB diagram is complete. Now the main diagram is left. Okay, the main diagram, that is MDB diagram. MDB, main distribution board diagram. There. There is a delta Y transformer. So it is 11 kV by 415 volt. Okay, line to line, 50 hertz. Okay, this from this transformer we give connection to the main distribution board, and from main distribution board there are actually 3 phase lines. If you do not use a generator, if your building don't have generator or PFI plant or water pump, you do not need to take 3-phase connection. You can only take single phase. But if we use water pump, which is basically we use, so there will be 3 lines, right? দিয়ে দিয়ে এখন কারো কালে দিয়ে So this is red, this is yellow, and this is blue. And আর কি জন্য হয় না I have told you that we have total 6 floors in this building. So there will be 2 units in each floor. So 1 SDB for 1 unit, 2 SDB for 2 units. So 2 SDB for 1 floor. So 12 SDB for 6 floors, right? So let's say this is SDB 1, SDB 2, SDB 3, SDB 4. But in your project, we have told you to design for 3-story building, not 6-story building. And let's draw lines for Y face. On Y face. SDB 5. I have told you this lab will take a lot of time, but we will not repeat the things. SDB 6, SDB 7, SDB 8. And let's draw 4 connection from this phase. So for 3-story building, there will be total 6 SDBs. So you can draw 2 connections from each line. SDB 9, 10, 11, 12. And we have already calculated the circuit breaker. Do you remember the circuit breaker from SDB to MDB? We have already calculated it. Where is it? Where is it? SDB to MDB, 40 ampere SPMCCB, 16 RM cable, right? You need to write it here again. So this all will be 40 ampere SPMCCB, and all these cables are 16 RM, right? Now let's assume that we will use a 5 kilowatt pump. So we'll take 3-phase connection for this 5 kilowatt pump, motor pump. Let's say it draws up to 15 ampere current, 15 ampere triple pole MCCB, and we know that for 15 ampere from the table, we know that the cable is RM cable, right? 4x4 RM. 4 RM and YY plus 4 RM BYA ECC. So you can see here that we are using 4 instead of 2. Can anyone tell me why? 131, can you tell me why? Everyone is asleep. Okay, so we are taking lines from 3 phase, right? So one is neutral and the other 3 is R, Y, and B. So there are total 4 wires, so 4 here, okay? And you can see how many power the pump draws by searching on Google, and you can also see the current rating of the pump. From there, you can also take a idea what type of value you should use. Next, we will use a PFI plant, power factor improvement plant. Actually, I didn't use PFI plant in my project when I was in Kuwait, but many groups have used PFI plant, and you are you also need to include PFI plant. Okay. PFI plant. And then the other connection, sequence connection, is for generator. So here we will use circuit breaker. This will go to LT energy meter We'll search on Google what is the function of LT energy meter and try to know yourself. Then these three wires will go inside a board. Board looks like this. So you can see that this is the generator. EMTV. So you can see that these switches, we can, these are now connected to the grid. Now we can also give connection to the generators when there is load shedding. So EMD will get connected to the generator while load shedding. Okay. Now we need to calculate the current ratings of all these circuit breakers and conduits used here. Wait 1 minute. Calculations for this is MDV. Calculations for EMDV. Calculations for EMDV. But we also know that in EMDB, before that, let's draw another connection diagram. After that, we will do the calculations. EMDB. So I am drawing this EMDB here. কোথায় হারিয়ে গেলাম? So EMDB. Now we have seen the connection of MDB from SDB, 12 SDBs, right? Okay, from EMDB. Here we also have three connections, R, Y, B. And total, oh my God, total 12 floors. So ESDB 1, 2, 3, 4. Total 12 ESDBs because there are total 6 floors. In each floor there are 2 ESDBs. ESDB 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. And we have already calculated this the current rating of the circuit breakers. Do you remember what was the current rating of the circuit breakers from ESDB to EMDB? ESDB to EMDB, ESDB. Here 30 ampere SP MCCB, 210 10 RM cable, 30 10, and from ESDB ground 5 1.5, 30 10 5 1.5, 30 10 5 1.5. So we have used 30 ampere SP MCCB and ten RM. Okay. Whew. And we have also used ESDB ground, ESB ground. Do you remember ESB ground? We have used here 5 ampere SPM CCB, and this cable was 1.5 RM cable. BYM plus 1.5 RM BYA SCC. Okay. Now there are also lift, right? What is here? One minute break, okay? I'm tired. Now we also need to show the connection of lift. So let's say we'll give this connection here because we want our lift to run even if there is load shedding. So we are giving connection here. But if you think that you will not run your lift when there is load shedding, you will give the lift connection in the SDB to MDB diagram. Okay. So here we'll use a automatic voltage regulator, and we will use a lift. Okay. Done. Now all the connection diagrams we have already drawn, all the connection diagrams. Now only the calculation of 2 connection diagrams have left. So we will calculate calculations for EMDB. Calculations for EMDB. So EMDB load, we need to calculate the EMDB load. EMDB load equals to total ESDB load. But it around, this is not ESP, it was ESP ground. It was ESDB ground, sorry, it was ESDB ground. Total ESDB load into 0.7 plus lift load. Lift load into 0.7. So can you tell me what is the total ESDB load? ESDB load. ESDB load is basically 12 into 12 ESB load plus 12 ESDB load plus ESDB ground load, right? So first calculate one ESDB load, then we'll multiply it with 12, and then we'll calculate ESDB ground load, then we'll add them up and we'll get total ESDB load. So what is this one, like load of only one ESDB? Load of one only ESDB. Let's find out where we have done ESDB. ESDB. Yeah, right? Oh my God. Circuit 1 prime, 2 prime, 3 prime, 4 prime. So we also need to calculate circuit 1 prime, 2 prime, 3 prime, 4 prime. Where is circuit 1 prime, 2 prime, 3 prime, 4 prime? We have calculated it previously. What was the total value of this one? 920, right? So multiply 920 with 12.
One 11040.
11040. Me to hara jai. This is 11. This thing is 11040. And ESDB ground load. ESDB ground. Where was ESDB ground? Here. We have also calculated ESDB ground load, right? Oh, actually, we previously calculated ESDB load. This is 4244, right?
Yes, ma'am.
Okay, so we do not need to repeat it here. Thanks God. 4244. So that was for just one floor, right? Sorry, one floor now. That was for just one unit. But we have total 12 units. So 12 into 4244 into 0.7 plus lift load. Let's assume lift load is 18.4 kilowatt. Okay. 18.4 kilowatt. Zero 0.7. What is the total value? Wait, we have skipped the ESDB ground load. Remember this 4244 watt was only for the ESDBs, not for ESDB ground. So ESDB ground load was 84 watt. Right? 84. And we do not need to multiply it with 12. Why? Because we have already multiplied it with 6, because there are total 6 slides in 6 floors in the staircase area, right? So we can just write it down 84 directly, or we can write 120 into 0.7. Yeah. Can you tell me the total value? EMTB load? What is the total value?
48669.6.
48.7 kilowatt, right?
Yes, ma'am.
Okay. 48.7 kilowatt. So this is the EMTB load. And EMTB current is look, this is important. Now give concentrate here. We know that 124244 into 0.7 and 18480 into 0.7 divided by so this is 84 here. 84, or you can write as I've told you that we have 6 floors, 20 watts, and load factor is 0.7 divided by 220 into 0.7. Because why we have used √3 here? Because you can see that we're taking connection from 3-phase lines, right? So EMTB current, this current, this current, and this cable, you need to use √3. But for the 6 lights we use single phase there, right? Can you calculate and tell me the total value?
182.7.
ভালো করে করছো 182.7 ampere. ওরাই মনে হয় ভুল করছে into line voltage. Line voltage into power factor. Line voltage তো হচ্ছে into 220. ঠিক আছে okay. Beshi current 150 ampere, right? 150 ampere triple pole MCCB. And MDB load was 48.7 kilowatts. So we can use 50 kilowatt generator, right? 50 kilowatt generator. So let us write here 50 kilowatt. Okay. We are almost at the end. Only one calculation is left. I'm giving you 2 minutes break. Hello. Hello.
Yes, ma'am.
Okay. Actually, I have done a little mistake here. Not a lot of mistake, little mistake. So the formula is like this. EMDB current, right? So EMDB current equals to EMDB load divided by √3 into line voltage into power factor. Or you can write EMDB load divided by 3 into phase voltage into power factor. Okay, so as I have used √3 here, so what I needed to use instead of 220? The √3 into 220, right? So actually line voltage is √3 into 220. What is the value? Hello,
381.05.
81.05 volt. Okay, So we actually needed to use 381.05. The reason is same because we are drawing lines from three phase, right? So we need to either you can use this formula or this formula. For phase voltage, you need to use 3 line voltage root. Okay, now calculate the current. Sorry, I'm
Ma'am, 105.7.
I was also wondering the current value should not be that much high. 10?
5.7.
105.7. 105.7 ampere. Now 105.7 ampere is we can use 120, right? 120 ampere. So we can write 120 ampere triple pole circuit breaker needed from EMDB to MDB. Okay. Now our EMDB calculation is done. We have already found out that 50 kilowatt generator and 120 ampere circuit breaker. Now we need to include it to the circuit diagram. Wait. Oh, actually, I have already written it here. 550 kilowatt, right? This is 50 kilowatt. And we have assumed lift is 18.5 kilowatt, right? 18.48 kilowatt. Okay. And what was left here? Yeah, here we need to write 120 ampere triple pole MCCB, and for 120 ampere we use 95 RM cable. So this will be 4 because 4 wires are going. 3 are for red, yellow, blue, and 1 is for neutral. 495 RM and YY plus. Now, when the current is really high, for example, it is 120 ampere, right? The current is really high. In that case, we do not need to use the same size for ECC cables. We can use a half size ECC cable. So we can use 48 RM BYA ECC. Okay. So for high currents, we can even make the ECC cable size half. Okay. Now, what is left? Lift calculation is left. We don't know this calculation. Wait. Everything is done. Calculations for MDB done. 40 ampere. How do we notice 40 ampere? So I think you should search it on Google. What type of lift you will use? Let's use 40 ampere MCCB here. Okay, 40 ampere triple pole MCCB. You know, you can also calculate the current. The current is for lift. The current is. Can you calculate the current? 18480 into 0.7 divided by root 3 into 381.05 into 0.7. Can you calculate it, please? Hello.
Ma'am, 28.
28, right? So for 28 ampere, yes, you can use 40 ampere triple pole MCCB because for 28, 30 ampere MCCB is really close, right? Okay. Now, let me check what is left. I have done SDV calculations, ESDV calculations, calculations for SDV, calculations for ESDV, calculations for SDV GND, calculation for EMDB is also done, calculations for MDB. Oh, calculations for MDB is left, right? So MDB load equals to total SDB load into 0.7 plus EMDB load into 0.7 plus pump load into 0.7. So total SDB load is basically 12 into 1 SDB load. So what was the 1 SDB load? Let's find it out. 1 SDB load, SDB. 5 to 1 to what, right? Hello? So 5 to 1 to is 1 SDB load. Okay. So we can write 5 to 1 to into 0.7 plus EMDB load. We have calculated EMDB load once, right? And pump load. The EMDB load was here, we calculated it.
4244.
No, this is the
Oh, sorry, 48.7 kilowatt.
48.7 kilowatt. There we have already calculated 0.7 here. We should not calculate 0.7 twice, right? Can you tell me the value without considering 0.7?
Ma'am, for lift,
Hmm?
লিফটের জন্য কি 0.7টা বাদ দিব?
Actually তো এখানে আমরা EMDB লোড, ESDB লোড আছে, লিফট লোড আছে, ESDB লোডের মধ্যে actually সবকিছু আছে। তো আমরা কিন্তু চাইলে কোথায় জানি ক্যালকুলেশন ফর MDB লোডের এখানে টোটাল 48.9 কিলোওয়াট লিখে দিতে হবে, 48.7, right? Because we have already calculated all these things there, right? Lift was also there. $48.7 kilowatt. Plus is there anything else in the MDB? Let's go to MDB. What is MDB? MDB, this is MDB. So MDB, here we have 12 SDB. Wait. This is MDB, right? Okay. Now let's again with MTB, and this is EMTB. We have already written down the value of EMTB, the final load of EMTB, including 0.7, and we have already included the 12 SDB, right? So what is left? Left is 5 kilowatt pump and the load of PFI plant, 5 kilowatt pump. Can you calculate this value? Hello. What is the total value here?
Nine five nine eight 0.8.
We have used power factor 0.95. Due PFI plant. Can you calculate the MTB current?
157.86.
Whatever. One 57.86.
ম্যাম একটু কম আসবে 153 আসবে ভুল লিখছিল
153. 153.86. Now 153 is, oh, we have missed 150, right? Let's use 150 RM. 150 ampere. Sorry, 150 RM cable and 200 ampere TPM CCB. And you need to do calculations for PFI plant. So can you tell me the sin theta below? Hmm?
Point 714.
714 and P tan theta, right? Sin theta equals to 1. Can write ABI and theta. I equals to Q by 3 by sin theta. Wait a minute. Hello? Could you calculate it? What is the value of Q? We have calculated the value of P, right? P is total MD value is 95.98 kilowatt. Now, can you calculate Q? You already know theta. So, what is the value of Q? 131. P is 95.98 kilowatt. Can you calculate it? Kilowatt is P. Everyone is asleep. Am I audible?
97.9.
90,
7.89.
97.89.
Yes, we can write it 97.
Okay. Then, what is the value of I? Here, sin theta, use sin theta 1.
ম্যাম ভি কি হবে? ভি
3 কিলো ওহম বুঝি নেই।
ওইটার নিচে কি 3v sin theta?
3v sin theta।
v এর ভ্যালু কি ধরবো?
220 এটা
0.148.
কি বলে 0.148? এটা কি ওয়াটে নিয়ে করো।
Oh. 148.50.
148 অ্যাম্পিয়ার, তাহলে হচ্ছে 150 অ্যাম্পিয়ার ট্রিপল পোল এমসিসিবি ইউজ করবো, এন্ড 150 অ্যাম্পিয়ারের জন্য যত আরএম কেবল থাকে তত কেবল ইউজ করবো। এন্ড হচ্ছে লাস্টলি ক্যালকুলেশনস ফর ট্রান্সফরমার। S equals to 3 VI, right? 3 into 220 into what was the current drawn by MDB? 153.86. Tell me, what is the KVA?
101.5 kVA.
101.5 kVA. Okay. So you need to use 101.5 kVA. So you need to use. You can also use 100 kVA because it is really close. Okay. So all the calculations are done. There is another calculation of pair terminal. I'm not going to show that. Enough for today. But all the calculations I have shown here, and you will need to show this also in your project. I did not show the calculations for the number of lights and number of fans because you already know how to calculate these things for each room. So the calculations today I have shown here are related to conduits and switchboard diagrams, right?
Yes, ma'am.
Okay. So any questions now about anything? Okay. Wait, I will take the attendance. Wait 1 minute. So you are A1 and C1, right?